Okay, so there's question 1, part B. So here's the practice exam number 3. You know, question A is easier. Let's do question B. 1, 3, 5, 7 all the way to 103. So 1, 3, 5, 7 all the way to 103. We'll make our rainbows. And so 1 connects with 103. The next one, what numbers are we putting up there? We're not doing all the numbers, are we? What numbers are we putting up there? Odd numbers. So the one right before would be 101. Right? So 2, 3. So they're all going to add up to be 104, aren't they? All the rainbows are going to make 104. So the question is, how many 104s do we have? How many 104s? There's a bunch of 104s, right? A bunch of rainbows, all the rainbows making 104. How many 104s are there? Yeah. 26. How do you know? Say that again.
I took the 103, added 1 to it, and then divided 104 by 2 to find how many numbers there were.
Okay.
And then I took 52 and divided that by 2 to find how many pairs. And so then that was 26.
Okay. So yes, so good thinking. You're saying, we're doing odd numbers, right? So there's half of them are there. Right? You with me? So if I said, how many odd numbers from 1 to 9? You'd basically go to 10 and divide by 2. And you'd get 5. Because you got to make it even, huh? So you got to go up by 1. Are you with me in that? Let me explain the reasoning that is being stated. It's very accurate. It's very good. 1 and 2, 3 and 4, 5 and 6, 7 and 8, 9 and 10. So 1 through 10 has what? 1, 2, 3, 4, 5 odd numbers, doesn't it? So you see what I'm saying? Whenever you stop at an odd, go 1 higher, because you got to get that even one, and then divide by 2. Right? Divide by 2. So if I take that, I should have left what I just erased there. But anyway, if you take 104 and you divide by 2, you get 52 odd numbers. So we don't need to divide by 2 again. It's just 52. So that makes sense. It won't be 26. It's 52. There will be 52 odd numbers. Does that make sense? Because there's 100 in the numbers 1 to 104. There's obviously 104 numbers. So if you divide that by 2, you get 52. There must be 52 odd numbers because half of them are odd, aren't they? Is that making sense? So we have 52 odd numbers. So we just take the 52 then times 101 because every rainbow makes 101, right? 52 101s. So I don't know what that is. Somebody have that in their calculator? Oh, yeah, thank you. I don't know what I'm doing. It's 104. It's 52 104s. Thank you. I messed up. It's 52 104s. Is that good? Does that make sense? 104 divided by 2 gives me 52 odd numbers. Does that make sense? Would it help if I wrote out the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again? You know, this is what I do. Have you noticed what I do whenever I'm stuck on a problem? I think of a simpler example. It's not just me. It's what every person trained in math, science, that kind of logical thinking. It's the way you attack problems. That is more valuable than memorizing certain formulas. Is the way to go about the thinking. Do you see what I do? I think, I don't know, 1 to 104, that's big. I can't write that out. So I just go, okay, I'm going to write 1 to 10. And see what's true there, and then apply that same truth to the bigger set. See that logic? So like a 1 to 10, if I wanted to know how many odd numbers, 1, 2, 3, 4, 5, I would just take 10 and divide by 2. Oh, so you just take the last even number, and you divide by 2, and that tells you how many odd numbers, doesn't it? So that's what I did. I took the even number that came after 103, divided by 2, and got 52 odd numbers, and then 52 times 104, which I'm hoping somebody will tell me, is 5408? 5408. So that's what they all had to be. Is that good? Yeah.
How come you don't apply the 52 by 2? Because that's how you amount of rainbows like there is. Oh,
you're right. I'm just like crazy today. It's good. It's good that I am here to show you how to think logically because I'm clearly so good at it. Yeah, no, you're totally right and I'm totally wrong. Thanks, yeah. No, so what am I messing up on? What am I messing up? I'm just counting the odd numbers, but so there are 52 odd numbers, that is true, but what I'm saying wrongly, is that a word? What I'm saying incorrectly is, yeah, there's 52 odd numbers, but every 2 odd numbers makes a rainbow, huh? So you were right from the beginning. I need to divide by 2 again. That's why you guys are all giving me a funny look. I wondered. When there's more than like 2 people giving me a funny look, that usually means I'm doing something wrong. So good. So it's half of this, right? What is that? So 2704? Is that right?
Yeah.
2704. Good. Yeah, thanks. Everybody see why that is? So I was just all focused on getting how many odd numbers. And there were 52 odd numbers, that's true. But then every 2 odd numbers makes a rainbow. So I can divide that by 2. There's 26 rainbows. 26 rainbows. I forgot about that. Good? All right, I'm just glad I could help you. Kathy stood on the middle rung of the ladder. She climbed up 4 rungs, moved down 3, climbed up 6, and she climbed up the remaining 3 to the top. How many rungs in the whole ladder? It's really just about writing it out. Do it with the steps. So I'll just start. Okay, Kathy stood on the middle. So here we go. I'm going to go right there. I'm just going to go. There's middle. It's important to label though. That rung will be the middle. Then she climbed up 4. So I'll go, okay, up 4. 1, 2, 3, 4. There she is right now. And then she moved down 3. So she's right here. Going to go down 1, 2, 3. Now she's right there. And then up 6. So then I'll go, okay, from here now, up 6. 1, 2, 3. And 4, 5, 6. 4, 5, 6. She's right there. Is that good? I'm just writing them in as we go. Am I going too quick? So Kathy started in the middle. She went up 4, then down 3, then up 6. And so I went some more marks up there. Up 6. And then what? Then she climbed up 3 more. So 3 more after that. After this, 1, 2, 3 more. To the top. So this one is the top rung. That's all the information I need. So I know where the middle is, and I know where the top is. So I know total rungs on the ladder, which is what they want, right? How many rungs on the ladder? Because if something's the middle, what does that mean about how many rungs are above and below it? It's got to be the same, huh? Right? If something's the middle, say this is the middle, then there's got to be, same amount above and below it, huh? So, how many above it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rungs above it. So there must be 10 below it, and then the middle is another one. So there must be 21 rungs. Does that make sense? 10 above it, 10 below it, 1 in the middle. 10 plus 1 plus 10. 21 rungs. 10 above, 10 below, 1 in the middle. 21 rungs on the ladder. All right, shall we move on? We good there? So just draw it out. The actual test today. So it's fresh in my mind. Super similar are the real test questions. So master these. All right. Find the 100th and the nth term for each of these. Yeah. Let's start with part A here. 1, 7, 13, 19. Let me just do it on a fresh one here. 1, 7, 13, 19. So they want the 100th term and the nth term. Okay, so what's happening from term to term here on number 3, part A? It's adding 6, huh? It's adding 6 every time, right? Add 6, add 6, add 6. So I gave you a formula. When it's adding the same number, it's called an arithmetic. Because arithmetic, when it's adding or subtracting the same number every time. The ones when they're multiplying the same number every time, that's called geometric. We'll do that I think, is the next problem. So right now it's arithmetic, and I gave you a formula, which it would be good. You get a 3x5 card, as usual, for this exam, right? And the formula is a sub n is a1 plus n minus 1d. So I gave you a formula for an arithmetic sequence. A1, let me tell you what these different pieces of the puzzle are. A1 is the first term. D is the difference or the jump from term to term. N is the number, well, N is the term number. Term number. Okay, so there's the formula. So let's give it a go. So a sub n equals a1. What's the first term? And right there, 1. Plus n minus 1. D, what's the difference from term to term? 6. Put that in there, 6. Okay, now, that's a fine answer. If you want to just give me that on the test, I'm good with that. That's the n. I kind of doing them in backwards order. That's the nth term. So that's the nth term. You can clean it up if you want to. I don't care. You can leave it that way. Or you could distribute here and get 1 plus 6n minus 6, which equals what? Minus 5 plus 6n. That's okay too. Either one, I don't care. I'm good on a test with either one. They're both right. Good so far? So that's either one of those. I'm fine on a test. There are the nth term formula. And now the one other thing they want from us is they want the 100th, right? Yeah, they want the 100th term and the nth term. So they want the 100th. How do I find the 100th term? I'll do it over here.
Plug in 100 into n.
Yeah, that means n is 100 into that formula we just found. Just plug 100 in there. So what's the formula say? Minus 5 plus 6n, and then just grab that 100, pop it in there. So we get minus 5 plus 6 times 100, that's 600 minus 5, 595. That's the 100th term. Yeah. No, yeah, good question though. It's going up by 6 every time. So it's plus 6. Yeah, it's adding. So the D is the difference from term to term. So it's going up by 6 every time. So this is the D on that one. So it's positive 6. It's going up every time. If the numbers are going down, that's when the D is negative. Good on that one? That makes sense? Let's try part B. Part B, 70, 100, 130. That's the same thing. I'm going to skip it. Let's go to part C, 1, 2, 4. So 3, C, 1, 2, 4, ... Okay. Now, what's happening from term to term here? Yeah, this is going times 2 times 2. So that makes it a geometric sequence. And that means when you multiply the same number. So you multiply the same number. So it's multiplying. So that's different than arithmetic. So I gave you the formula for that. That one is a little different. A sub n is a1 times r to the n minus 1 power. And again, a sub 1 means first term. R is the ratio, which means it's the number multiplied each time. It's the ratio. We call it ratio because if you divided any term over the previous term, you would get that ratio. You know what I mean? If you took 2 over 1, right? If you took 2 over 1, you'd get 2. Or if you took 4 over 2, right? 4 over 2. See how you always get that ratio? Because that's the number being multiplied every time. That's why we call it the common ratio. Okay, anyway, so let's wrap it up here. So a sub n is the first term. What's the first term? 1 again. It's not always 1, but has been a couple times here. 1 times r. What is r? 2 to the n minus 1. There we go. That's the nth term formula. That's the nth term. And now, last thing is they want the 100th term. How do we find the 100th term? Plug in 100, huh? It's 1 times 2 to the 100 minus 1, which is 2 to the 99. We'll just leave it that way. You don't have to do it on your calculator. It's gigantic, crazy big. Let's just leave it 2 to the 99. That's the same way I'll do it on the test. Just let you leave it that way. Because it's too big. It's crazy big. Is this making sense? So you want to have on your 3x5 card for the exam on Monday this geometric formula, and the one we just did here is the arithmetic formula. Arithmetic when it's adding or subtracting the same number every time. Geometric when it's multiplying the same number every time. Questions on those two? Yeah.
Do you know if for the practice exam they want us to put it in like that, or is it like?
Yeah, just like this, 2 to the 99. Yeah. Is 9, 9, 3, 9, 5, 9, 7, Am I doing that right? Yeah. Okay, same thing. All right, so I think I might have done this wrong before on the YouTube or something. I had a couple people telling me. Anyway, whatever. Let's do it right this time. So how do we get those powers up there? Notice the 9 is just a fixture, right? We're not doing anything with that. It's just all that's changing is the powers. 1, 3, 5, 7. Now I know we all know those are odd numbers, but we need to say something more than the fact that they're odd numbers. What's when you go from odd number to odd number, what are you adding each time? You're adding 2 every time, aren't you? So we're adding 2 every time. So that means it's an arithmetic, isn't it? Remember arithmetic? That's the first thing you did in math when you were a young'un. You did arithmetic, that's adding, subtracting. So we call it an arithmetic sequence when it's adding, subtracting the same number every time. So it's arithmetic. So I'm going to use a sub n is a1 plus n minus 1d again. So what's the a sub 1? Now we're just talking about the powers, huh? Just the powers. The first power is 1. And the difference is 2. Is that good? So the a sub 1 is 1, the difference is 2. And then distribute that. So I get 1 plus 2n minus 2. I get, what's that, minus 1 plus 2n. Everybody good there? So I'm just combining numbers, right? 1 and minus 2 made negative 1 plus 2n. So what's the formula then? Let me bring it over here. What's the formula? It is 9. It's a funny looking 9. It is 9 to the minus 1 plus 2n. So you got to put that 9 back in there. That's the nth term formula. 9 to the power minus 1 plus 2n. I know I'm going kind of quick. I'm trying to get through as many of these as I can for you. But do you see how that's really true? Do you see if you let n be 1, what will that be? If I let n be 1, that'll be 9 to the power, negative 1 plus 2 times 1. What's negative 1 plus 2 times 1? Negative 1 plus 2 is 1. It's 9 to the 1, which is the first term. 9 to the 1. Huh? See, if I put in 2 for n, it'll be negative 1 plus 2 times 2. Negative 1 plus 4 will be 3. 9 to the 3. See how it's working perfectly? As you let n be 1, then be 2, then be 3, it'll go 9 to the 1, 9 to the 3, 9 to the 5. See, let it be 3. It'd be negative 1 plus 2 times 3, negative 1 plus 6, 9 to the 5. Perfect. So that formula is the truth. It's giving us the pattern. And then finally they want the 100th term. So what would be the 100th? Just plug in 100, huh? Minus 1 plus 2 times 100. That's, what is that, 199? 9 to the 199. We'll just leave it like that. 200 minus 1. We good with those? Questions on those? So I just did the powers and put the 9 back in at the end. All right, I better move on so I can get as many of these done for you as possible. That'll be okay. And then next comes 108 plus 6 times 3 to the 27th. And the next one is 108 plus 7 times 3 to the 27th. Dot, dot, dot. All right, so we see the pattern. The only thing changing is 5 becomes 6, becomes 7. So that's the only part I'm going to focus on. Does that make sense? The rest is a fixture, which I'll put back in at the end. So I'm really just going to say, hey, 5, 6, 7, blah, blah, blah. That's what I got to figure out with an in formula. And when I get it, put it back in next to the 3 to the 27th. Huh? All right, so how do I figure out 5, 6, 7? What kind of a sequence is 5, 6, 7? It's another arithmetic. It's just adding 1 every time, isn't it? You with me? It's arithmetic again. It's arithmetic, adding, subtracting. Okay, so that means it's a sub n is a1 plus n minus 1d. The a1, what's the first term this time? Yeah, this time the first term is 5. Right, first term. And the d, what's the difference from term to term? 1. Everybody good so far in the arithmetic formula? The first term is 5 and the difference is 1. So then distribute 5 plus n minus 1. That's 4 plus n. There's the formula, 4 plus n. So then putting it all together, we've got the nth term is 108 times 4 plus n. Whoops, getting kind of scribbly there. 4 plus n times 3 to the 27th. Is that making some sense? Maybe if I change the color to be more clear. Oh, this is supposed to be plus, isn't it? Did I mess that up? There we go. So 108 plus, and then right here I put my formula, 4 plus n times 3 to the 27th. So the rest of that stuff is a fixture, and I put in the formula right here. And then if they want the 100th term, I can do that. Plug in 100 for it. So that'd be what? 4 plus 100 times 3 to the 27th. So that's 108 plus 104 times 3 to the 27th. We'll leave it just like that. 108 plus 104 times 3 to the 27th. I'll let you copy that down. Good? Questions on that one? Okay. How do we find the ones digit for 3 to the 50th? It's kind of a crazy question, huh? Like, what are they talking about? You guys have your calculators? Can you do 3 to the 50th on your calculator? So if you do 3 to the 50th on your calculator, Can I check your calculator? Thank you. So yeah, so I'm getting this is probably what most of y'all are getting. 1.55541169. And then it depends how your calculator is set up. Might have a little 22 up there. Might show 10 to the 22. Something like that. So what does that mean? What's that little 22 kind of floating up there like that? What's up with that? What does that 22 mean? This 22 right here. What's that? What does it mean? Not 22 more numbers. it means the decimal right here, which has been artificially placed right there, needs to go 22 places to the right. Does that make sense? That's scientific notation. It really means times 10 to the 22. Maybe your calculator shows the 10. Maybe it doesn't. Anyway, my point is, the decimal, it means decimal 22 places to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's only 9. It's supposed to go 22 places to the right. I'm already to the edge. It's supposed to go 22 places to the right. Remember that scientific notation? Right? So I don't know what the rest of the digits are. They're not just zeros. They're whatever they are, and I don't know what they are, and your calculator's not telling me. All of that was to point out your calculator can't help you here. Does everybody see why we have to use a logical pattern instead? Does that make sense? The calculator can't show me that many digits. This is a number that goes 22 places to the right. So it's not able to show me the ones digit is the last digit, huh? They're asking me for the last digit, the ones digit. The calculator can't show me that. So what do we do? Does anybody remember how we did this one before in the homework? Yeah.
You listed it like 3 to the 1, 3 to the 2.
Yeah. What is all of math and science about? Why are we doing this? So that, because it's an important job skill for your life, that you be able to find the ones digit of some wacko crazy number. No, nobody's going to ever ask you to do that. But why do we do this stuff? Because we're learning to think patterns, and for you all to teach others, future engineers and scientists, how to think about patterns, because that is super valuable. That's the basis of all math and science, is the ability to deal with patterns. Yeah, so let's look at the pattern. 3 to the 1, this your calculator can help you with. 3 to the 1 is just 3. 3 squared is 9. 3 cubed is 27. 3 to the 4th is 81. Right, just keep multiplying by 3 on your calculator. 3 to the 5th is, 243. 3 to the 6th, I think, is 729. 3 to the 7th, there's my limit, 21 something or other. 2116, 2187? Is that right? Okay. 3 to the 8th, I don't know, 60, I don't know, 6,000 something. Somebody got it?
It's 65 and 61. So 6,000
6561? Yeah, now what are we looking, why are we doing all this? What are we looking for? We're looking for the ones digit, huh? Look at what's happening. You see what's happening with the ones digits? 3971. 3971. Do you see how it's repeating a definite pattern in the ones digit? 3971, 3971, 3971, 3971. It's going to keep doing that. Okay. So, and we're up to 3 to the 8th here. We want to get to 3 to the 50th. How can I find out what the 50th, if we go all the way 3 to the 50th, what the ones digit's going to be? So here is our ability to deal with a pattern and do something with it. You see the pattern. That's one step. But actually being able to manipulate the pattern is a little bit higher skill. That's what we're trying to gain on this problem. So how do we make much of that pattern? How do we say, okay, I see the pattern, I'm going to wrench it, I'm going to leverage it to find the ones digit of 3 to the 50th. What do we do?
Divide by the number of digits in the pattern.
Yeah. Which is 4. You divide by how big the cycle is. Yeah. This is a repeating cycle of 4 digits. Do you get it? It's kind of like on the last test or the first test? I can't remember. Where I said, hey, what if everybody marched into this stadium? I think that's where Janelle said she'd be today. She's marching band is out there practicing or something. So what if the marching band was going to march into the stadium and they were going to come in with numbers? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4 as they come in, right? First person marching in has a 1. Then the person right behind him has a 2 on their shirt. Then a 3, then a 4. Then they start over again. 1, 2, 3, 4, 1, 2. And I said, hey, what's the number on the back of the 50th person? They go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So what's the 50th number going to be? What would you do? You would have to say, well, I'm going to long divide 4 into 50, huh? Because I got to see how many whole groups of 4 come in Because they just restart every group of 4, right? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Even though we're not doing 1, 2, 3, 4, we're doing 3, 9, 7, 1. Same deal, whatever. They could have A, B, C, D on their shirts. Whatever. They're just repeating, or they could have dogs. There we go, that's much more appropriate, huh? D-O-G-S, D-O-G-S, D-O-G, right? As they march into the stadium. So what letter are they going to end up at if they're marching in with repeating D-O-G-S, 4 letters, on their shirts? I'm really impressed that I thought of dogs. Aren't you impressed? I thought that was very, very appropriate. All right, anyway. I'll quit being impressed with myself. It doesn't go far. What do we do? What do we do now? We say, well, how many full cycles are in the 50 there? How many full cycles of 4 are in the 50? Well, if we long divide, get 10. How many? 4 goes into 10? 2 times. 2 times 4, 8. Remainder 2. Right? Now, what does that mean? When we say the answer is 12, that means 12 groups of 4 digits. Doesn't it? 12 whole groups of 4 people will come in. Right? 4 goes, so this is really thinking clearly about long division and what it means. That means there's 12 groups of 4 and 2 remain. Doesn't it? That means a whole group of 4 will go in, another group of 4, another group of 4, another group of 4, another group of 12 groups of 4, and lastly, the last 2 people will go in. And so in the last group, the first person will go in will be 3, and the last group, and the next person will be 9. So 9 is the ones digit. It's the ones digit for the 3 to the 50th, isn't it? 9 is the answer. Do you see that? The power of a pattern. The power of pattern. Technology couldn't help us, right? The calculator couldn't do it. That's the fuel of all math and science, is that kind of thinking. Logical pattern thinking. Is that good? You'll be able to do that in the test? That's for sure on the Monday test, something like it. Right? So just draw out the pattern, long divide. The remainder tells you how many remain in the last group. So how many steps to go into the cycle the last time. 2 steps in, 9's the digit. Good. Number 5, part A. So I'm going to have 3 of these. I will put this 3 on the exam. There's one question basically that has 3 of these, 3 ones like this on it. And it's just all about following the pattern. So this will be about all the time we have to work through this one. So do you see the pattern on part A? What's it doing? Yeah, 713, 713. So 713, 713. Easy. That one's easy. And I'll ask you to write write words. Not a lot of words. I don't need like a 3-paragraph sentence, I just want you to write repeating 713. So on the test, like I said, there's one question that has 3 of these, A, B, C. And I'll say fill in the next 3 and write with words what pattern you were observing. And you would just write repeating 713. That's all I'm looking for. Just to make sure I'm understanding what you were seeing there. Let's try the next one. So look at B for a minute. And notice they're giving you like an ending one here too. This is, by the way, exactly what science does. This is what they do in science. They look at something in the sky or in the human body or whatever, and they see things happen, and they think, what's the rule making that happen? That's exactly what science does. It's called inductive logic. They see and they induce from what they've seen. That's called the scientific method. Right? When they look at something, observe, and then predict. So it's like we're doing that same kind of thing. We're looking with just numbers, and we're saying, okay, I'm looking at this. Somehow it has to end with a 6. What's the rule? What's the underlying rule there? What's making that happen? Anybody see a rule that's at work there? What would explain what we're seeing? What orderly rule would explain that? Like Einstein said, you're trying to think the thoughts of God as you look at physics and what rules are behind it all. So what's the thought there on B? Anybody?
We're adding a number to it.
Adding a number? Oh yeah, like one more each time? Yeah, I think so. 2, 3. 2, 3, 4. 2, 3, 4, 5. 2, 3, 4, 5, 6. Beautiful. Yeah. So you know how science works, right? They wouldn't have that 6 at first. They would hypothesize something. It's called scientific method. They hypothesize. They go, I think it's going one number further every time. And then they say, if that's true, then we should find a 6 when we do whatever. When we see further with, some Hubble telescope, or see further into the cells with the electron microscope, see smaller things than we could ever see before. And then they predict with their theory, then they would say, I think the next one should be a 6. And when they see that, they go, yes, I think we're getting the rule that's there. That's exactly how science works, huh? All right. So, good. And so what would you write for that? I don't care what you write. You can say, going one number further each time. I'm not looking, I'm not an English teacher. I'm pretty casual about what you write, as long as it generally gives me the idea. Going one number further each time, or adding one number every time, all that's good with me. How about the next one? How about part C?
You're adding the first two numbers to get the third number, the second and third number to get the fourth number,
Etc. Yeah, does everybody see that? 1 and 2 add to be 3, huh? And then 2 and 3 add to be 5. And 3 and 5 add to be 8. So you're just adding the two previous numbers every time to get the next number? Right? So what would be the next one? 5 and 8? 13. And then 8 and 13, you can just calculate 21. 13 and 21, 34. 21 and 34, 55. Perfect. All right, let's keep moving. I won't write out words. Just whatever. You just add. You can write whatever there. Let's try the next one. How about part D? What are we doing on D? We got to look at that. Just 3 steps down the line. You're 256. What happened? Those numbers got big in a hurry. What explains that pattern?
It's the same thing you'll multiply.
Yeah, same thing, but just multiplying. Good observation. Good observation. 1 times 2 is 2. You multiply the 2. 2 times 2 is 4. So let's see if it works. If that's really, well, then we'll go forward and somehow we should hit 256. Let's see if that's right. 2 times 4 is 8. And then 4 times 8 is 32. And if you take your calculator, 8 times 32, it is 256. Good. All right, how about E?
It's 2 patterns in one. Oh, wait.
Oh, we'll get there. Yeah, E, just E.
You're adding 3.
Yeah, E's easy, huh? We're just adding 3 every time, right? Is that one good? Just add 3. So 13, 16, 19, 22. Yeah, let's go on to F. So, Carolina, what's F?
2 patterns in one.
Yeah, F's a tricky one. F would take some time to stare at. Yeah, look what Carolina's observing. Remember this one from the homework? 2, 5, 8, 11. See how those are just going up by, 3 every time? Every other, it's 2 patterns. They've interspliced them. So it's going up by 3. So if you jump to here, go up by 3 would be 14. Go up by 3 would be 17. Perfect. Go up by 3 would be 20. That's perfect. And then the other numbers, what are the other ones doing? 3 to 5, 5 to 7. Just going up by 2, or odd, however you want to say it. This would be 9. This would be 11. This would be 13, etc. Is that making sense? It's 2 patterns interspliced. So this is all the different kinds of things you want to look for on the test Monday. I'm going to give you some mix thereof for these. How about G? As time is running on us here, what's going on G? Yeah, it's going down by 8. Is that what it is? Yeah, 8 every time. So it just keeps going down by 8. So this would be 30, 22. Down by 8 would be what? 16? No. 14? 14, and then down by 8 is 6. Perfect. That's right. It's going down by 8 every time. Last one. What's happening in 2, 6, 18? Times 3. So this would be 30, 54, 150, 162, and 486. Well,